3, 2, 1.
Listen up, y'all, cause this is it. The numbers we're making are so vicious. Mathematicious, expeditious, can be kinda scary. I hope my answers are radical or imaginary. I convert percents to fractions.
All right, how's everybody doing? Well, as we talked about earlier last week, we are on to quadrilaterals. This is chapter 7.4. We're going to talk about different types of shapes that have four angles and four sides and see how they have similarities and how they have some differences. Okay, I guess to begin with, what is a quadrilateral? Well, a quadrilateral is a polygon with four sides. The diagram, which I'll show you here in a moment, shows properties of different types of quadrilaterals and how they are related. When identifying quadrilaterals, use the name that is most specific. So we talked about that earlier with the triangles, how you could call it an acute triangle, but if all three angles are 60 degrees and they're the same, then it's more specifically an equiangular. This is very true with quadrilaterals, even more so, to be honest with you. Let's take a look at this. So again, at the very top, you see just a quadrilateral. Any shape that is closed, a polygon, that has four straight sides and four angles, again, it's a polygon, is considered a quadrilateral. Then, from there, we kind of begin identifying specific types. So we'll begin with the oddball. The oddball of the specific ones is a trapezoid. The trapezoid, the only thing that makes it a trapezoid is it has exactly one pair of parallel sides. That's all it takes to be a trapezoid. There are different types of trapezoids, but all it takes to be a trapezoid is you have to have exactly one set of parallel sides. Now we'll begin with, we'll do the next one. We have what's called a kite. A kite is a quadrilateral, two pairs of congruent adjacent sides. Remember, that means that the sides are next door neighbors with each other, and opposite sides that are not congruent. Okay, so we have, again, two pairs of congruent adjacent sides and opposite sides that are not congruent. Okay, and then parallelograms, rectangles, rhombuses, rhombi, and squares. These are all in the basic family, I guess, underneath the shield of parallelogram. So a parallelogram, this is a shape that has two sets of parallel sides, two sets of congruent sides, and two sets of congruent angles. Okay, so again, the opposite sides are going to be parallel. The opposite sides are equal, and the opposite angles are congruent. That's all there is to be said about it. It can be interpreted many different ways. For example, a rectangle, which is a specific type of parallelogram, it has four right angles, right? Which would also be the same thing as two sets of congruent angles that are opposite of each other. Just what happens is they're all the same, but it still meets the specifications of a parallelogram. It has two sets of congruent sides. They could all be the same, but they don't have to be. They just have to be opposite ones are going to be congruent. Again, just like a parallelogram. The big difference, and they have two sets of parallel sides. The big difference is a rectangle must have four right angles, where a parallelogram just has to have two sets of congruent angles. That's what makes these two different, and that's what makes a rectangle a specific version of a parallelogram. A rhombus. A rhombus, again, is just like a parallelogram, as it has two sets of parallel sides, and it has two sets of congruent angles. The one difference is, to be a rhombus, all four sides must be the same length. So it's just like a parallelogram, except for all four sides must be the same length. And then finally, we have the most specific one. This is a square. While it does have two sets of parallel sides, you must have four congruent angles and you must have four congruent sides. So the rhombus and square share similarities, the rectangle and the square share similarities, and the parallelogram and the square share similarities. The key thing is this. Any square that you pick is a parallelogram. However, there are only some parallelograms that would be considered squares. Now, one more thing I want to talk about before we move on is the one thing we can do, which would be like the always, sometimes, never game. So, for example, a trapezoid can never be a parallelogram. A trapezoid can never be a rectangle, it can never be a square, it can never be a rhombus, and it can never be a kite, because a trapezoid has only exactly one pair of parallel sides. The other ones have two pairs of parallel sides. The kite have none. And then a square, for example. A square is always, all squares are considered rectangles. So a square is considered a rectangle always. If I was to say a rectangle is a square, you'd say sometimes, because it can. However, I could say, well, what if the side lengths are different? Then in that case, it would not. But some rectangles are considered squares, just like some parallelograms are squares. All squares will be considered parallelograms. I guess the more specific a shape is, it's tougher to be that shape. However, that specific shape, like the square, could be all squares are considered rectangles, all squares are considered parallelograms, and all squares will be considered a rhombus. So we'll take that with a little bit of practice. Just all you have to do is whenever you look at a shape or look at a comparison, just make sure, does it meet the requirements needed to be that shape? Okay, classifying quadrilaterals. So for A, let's just focus on the picture. This is a square, as you can tell, because it has four right angles and it has four congruent sides. That is the most specific thing you can have, so it is considered a square. Again, it has four congruent sides and it has four right angles. Yes, it is a rectangle, and yes, it is considered a parallelogram, and yes, it is actually considered to be a rhombus, and all of these are considered to be a quadrilateral. However, the best answer you can give, the most specific, is a square. Now our next one, the two adjacent sides are going to be congruent with each other, and there you can see there are no parallel sides, so therefore this must be a kite. Okay, again, it has two pairs of congruent adjacent sides, and opposite sides are not congruent, so again, it is a kite. Take a moment and classify 1, 2, and 3. Okay? All you have to do at this time is just to classify it. All right, go ahead.
All I do is show up, talk no matter what. That's just some on my mind, I can never get enough. And every time I step up in the classroom, all my students' hands go up, and they stay there.
All right, well, let's take a look to see how you guys did on this. So for our first quadrilateral that we see, what do we know? Well, we can see that we have two sets of parallel sides. And we have, the big thing is we can tell that we have four sides that are all the same. We can assume that the angles are not all the same, specifically because it's not noted, that they're all right angles. But even by looking, we can tell there are two acute angles and two obtuse. But because it's not noted they're right angles, we cannot assume they're right angles. So all we know is that we have four sides that are the same, which makes this a rhombus. Our next one, the only thing that we really know, that we need to know, is that we have one and only one set of parallel sides. Therefore, this is a trapezoid. It's a really bad looking D, isn't it? Here we go. Let's try that again. There we go. And then finally, this is what we know. We have 4 right angles. So it narrows it down to rectangle and square. And then for this one, we have 2 sets of congruent sides, but they're not all the same. So in this case, this is a rectangle. Okay, let's go ahead and move on. Okay, so our next key idea is how we're going to find, basically it's going to deal with how to find the missing angle of a quadrilateral if we have maybe 3 of the missings, 3 of the angles, and we're to find the missing angle, or something along those lines. But the key idea is this. With all quadrilaterals, no matter what they are, if you add all 4 angles together, they always equal 360 degrees. So if I have x, y, z, w, or w, x, y, z, those are my angles. If you add w, x, y, z together, you're going to get 360. Okay, every quadrilateral this is true. So for example 2, it says finding an angle measure of a quadrilateral. So it says find the value of x. So in our problem, we have 3 angles. We have 115 degrees, 70 degrees, 75 degrees, and then x. So the work I want you to do, I want you to find out the sum of the 3 angles. So we have 70 plus 75 plus 115, and then you're going to add it to x, and you're going to solve that equation. So you're just going to subtract the sum, which is 260, from both sides, and you get x equals 100. So I do expect to see this work. I do expect to see this work. All right. Even if you start with this line, I'm okay if you start with that line, but you do need to show your work. I want to see the equation just to get you in that habit of setting up an equation to find the missing sides. It will come in handy later on, especially if we have a problem where you're given different values that aren't just numeric values for the angles. All right, just trying to build good habits. So the other example is going to be dealing with constructions of quadrilaterals. So these are the steps. So the instructions say draw a parallelogram with a 60-degree angle and a 120-degree angle. And so this is what we're going to do. Like we've done with the other constructions, we're going to start off by just drawing a straight line using your straight edge. And then it doesn't tell you anything about side lengths. So all you have to do is make your first angle, like the one they show on the left-hand side, make it 60 degrees. And then you're going to make on the inside part. And then you're going to make another angle. Now, the way they show it is the inside should be 120. However, if you want to, if the inside is 120, that means the outside has to be 60 right here. So if you want to make both this angle here 60 and this angle here 60, you're going to come up with the exact same angle measurements for these sides. Or if you want to, you can make the inside on the left 60 and the inside on the right 120. It makes no difference. But that's what you have to do, is you have to make 2 angles, and then you're just going to draw the lines up top to connect it, and then just erase the marks. That's all you got to do to make a quadrilateral with a protractor. All right. So let's go ahead and see how you do. At this time, you're going to find the value of x for both 4 and 5, and then you're going to go ahead and draw a right trapezoid. All that means is that you have one angle that is 90 degrees. And so there's no confusion. The reason it's only one side that's 90 degrees, if you had more than one angle that is 90 degrees, they would all have to be 90 degrees. Let me rephrase that. If you had two angles, well, I guess it would really be three or more right angles. It'd be a square or a rectangle. But just one of your angles is going to be a right angle, and then you're going to have parallel sides lengths, which would be 3 centimeters and 5 centimeters. But actually, if you have one angle that is 90 degrees, you will actually end up having two angles, but no more than two angles that are 90 degrees. You can't have more than that because then it becomes a square or rectangle. So anyway, let's go back to 4 and 5. You guys give this a try, see how you do. I'll be back.
Math. 3 minus 4 is...
-1.
That's right. And 6 times a billion is...
6 billion?
Nailed it. And 54 is a 45 more than what is the answer, Marta?
9.
No, it's 8.
No, it's 9.
Yes, I was testing you. It's 9. And that's a magic.
Okay, well, let's see how you guys did with this. So for number 4, we're going to have, again, I don't mind if you add them ahead of time if you can do it easily. 100 plus 100 is 200 plus 80 is 280. So we have 280 plus x equals 360. We're going to subtract 280 from both sides. And we get x equals 80. And that is our missing side. All right. And then for our next one, we're going to have 81 plus 90 plus 124 plus x equals 360. Yeah, the three numbers together, we end up getting 295 plus x equals 360. Subtract 295 from both sides. And we get x equals 65 degrees. All right, let's move on to our very last problem, and we will finish this off. So it said, draw a right trapezoid whose parallel sides have lengths of 3 centimeters and 5 centimeters. So for this, you're going to start off by drawing your straight line. And then what I did was I drew my right angle, and then I went ahead and had another right angle. Oops, sorry. You'll see here. Hang on, let's see. Then I had another right angle up top, which was right around here. And I was able to then draw a parallel side. And it was key to make sure that the parallel side was 3 centimeters and over here. And then down here was 5 centimeters. So basically we're looking at the two right angles. Those are the only two right angles. And then we have the two parallel sides are 5 and 3 centimeters. And then you're just going to connect the two endpoints on the right-hand side. That's all you should do. Hopefully this made total sense to you, and best of luck moving forward.